Okay, no intro on this one. So let's just start with number 11. Let's see. It's known that 15% of seniors in high school enter the military service. Graduation, a group of 20 seniors are randomly selected. What is the probability of observing at most one senior who will be entering military service? Okay, at most means, well, you could have a situation where nobody goes into the military or just one person goes into the military. So you have to figure out those two probabilities. So here's the formula right here. Okay, looks scary. But one thing we need to remember is right here, this is like the N choose R in the calculator. So for instance, if I wanted to know how many different ways could I have a situation where out of 20 people, none of them go into the military. Well, in the calculator, you would put 20 first, and then you go and press the button that says math, and arrow over to where it says probability, and it looks like this. N, C, R. And we would put 0. How many ways are there to do this? Well, there's only one way. Okay? They all have to do it. Okay? So, So these are the guys and girls that are not going into the military, and these are the ones that are going into the military. So let's take a look at this, right? Not going into military. So our situation is nobody's going into the military. We're all 20, okay? All 20 of them, okay? So it's 0.85 to the 20th power. That's what that situation would be. And then over here, they are going to go into the military. So that would be 0.15 raised to, well, it's the 20 minus 20 power, which is 0.15 to the 0, which is 1. Okay, so that's kind of a mess. But we end up with this first situation where we say, well, after all that, this becomes 1, this becomes 1, we're just multiplying. So we end up with the fact that if none of them go into the military, well, that would be 0.85 raised to the 20th power. Okay, that's the first piece of our answer. Now the second piece is, what's the probability that one person goes into the military? Well, we still have to do this. We're going to do 20 choose 1, right? Okay, so we'll put that in the calculator. Like we said before, it's 20 NCR1. That's an R. So how many ways could we do that? 20 people picking 1? Well, there's only 20 ways to do that. Now the calculator would tell you that. Okay, so that's the first piece of the formula, which is over here. And now we're going to deal with this. So we would say, well, one person going into the military, well, it would be 20, it would be 20, right? The number we just figured out. So now we're going to work with this thing. So people not going into the military, 0.85, and 19 of them are not going to go in the military. And then 0.15, one of them is going to go into the military. So that's how we figure all that out. And then we have to add these two things together. So it's right here. And plus this thing plus the other thing. Okay, this represents, just one more time, nobody's going in the military, right? 0.85 is the fact that they choose not to go in the military, and all 20 kids say no. This is a situation where 19 of the kids are not going to go in the military, and 1 is. So that's when we say at most one person. And what choice is that? Looks like it's letter C. Okay, there's that question. Let's try the next one. Don't get discouraged if you missed number 11, if you didn't know how to get it started. That formula is on the formula sheet. Okay, it's on the probability section, about halfway down. So we'll get the hang of it. You just got to work at it. Here is number 12. Okay, so let's see. They're going to use St. John's wort to reduce depression. Now, it looks like the 100 people take St. John's wort and then they take another thing. So it's the same person that's doing this thing. That's why they're going to do a 2-sample t-test. You would put the results into list 1 and the other results into list 2, subtract them, and use list 3 for your test. But anyway, let's take a look. They are really just asking you do you know what a p-value is? So the p-value is 0.42, which is pretty high. We would expect to see these results. Now, I'm not even reading the answers. We would expect that we would get these results 42% of the time, assuming that St. John's wort does nothing, right? That the results are the same. Okay, so in other words, we would fail to reject the null hypothesis. We can't really determine whether it's working or not. Now I'm going to look at the choices and see how they reword this to try to trick me. Okay, let's take a look. Okay, letter A says, about 42% of the time, samples drawn from populations with no difference in mean depression count would show a difference of at least as extreme as that found in this study. That sounds right. But let's take a look at the other ones. 42% of the participants did not experience any relief. Nope. There were 42% drop in the mean number of days of depression. Nope. There was a 42% drop in the mean number of days of depression in the group that received the St. John's wort. Nope. There was a 42% drop in the difference of the number of days of depression between the two groups. No. So the only one that's even close is A, and that is the correct answer. So, boom. A. Maybe you got that one right. Hopefully you, after reading this question, you could cross off a couple of these choices. It wasn't a simple random sample. The key is that they go into the marina and they ask everybody in that marina. So that's kind of like, remember when we talk about if we wanted some information, you would go into a classroom and ask everybody in the classroom. So that classroom kind of represents the entire population in that way. And that would be a cluster. Okay. So remember, stratified would be maybe everybody's in the gym and you take 10 students from the freshman section, 10 from the sophomores, 10 from the juniors, 10 from the seniors. That would be stratified. But this was, you go in the marina, one marina, and you ask every single boat owner in that marina. Okay, so that little pod right there, that's a cluster. Okay, so there you go. So on this one, I'm hoping that you were kind of like, yes, I actually know this one. Okay, so here we go. What is this question saying? You're testing to see if the cereal maker's claim is true versus you think that they have less than 48 ounces in their packages. So what you would do is, for sure, cross this one off, cross this one off, cross this one off, because they don't have the equal sign. Okay, so the null hypothesis always has an equal sign. We assume that no change, right? Yes, they have 48 ounces. Yes, they have 48 ounces for the null hypothesis. But our alternative hypothesis is, well, which one is it? Well, we're testing. It says in the question that they think that it holds less. So the answer would be A. Okay, here's the situation. The reporter thinks that there's a quota for police officers, right? Which means that if they didn't make their quota, they would have to write more tickets on the 4th week to make their quota. Now, if they didn't have a quota, you would probably notice that it should be about the same number of tickets per week. Now, this reminds me of that babies born each day of the week, right? It should be about equal for each day. Now that also, I start to think about, so this must be chi-square, and it might even be chi-square test for homogeneity. Now, I haven't even looked at the answers yet. And it makes me feel good because two of them are chi-square answers. I'm still going to look at the other answers, but I'm kind of feeling good about the chi-square. So I'm going to cross these off. So now, is a chi-square test for independence, or is a chi-square goodness of fit? It's the independence would be one of those things where you have like a matricy, right? Kind of thing. So it's chi-square goodness of fit. So good old Goff. Okay, there you go.